Alright, we're on section 10.8. Again, it's on circles. This is the very last section of our chapter. So that should be exciting, shouldn't it? And what we're going to do is we're going to do a thing called the equation of a circle. Before I started recording, we talked a little bit about knowing the equation of something. The equation of a what? What have we talked about in the past? Of a line. What was the equation of a line? Y equals mx plus b. Correct. Equation of a circle. But this time we're going to do a circle, all right? Not just a straight line. So in order to kind of show you where this equation comes from, I could sit here and just show you, okay, this is the equation of a circle. All right, but what I'm going to try to do is I'm going to try to show you, I'll try my best to show you where this equation comes from. Let's actually do this in a different color. All right, I'm just going to put this anywhere at all. All right, so I just chose that spot right there. Whoops. And that's all I want to do for that. And I'm going to put a point right here. All right, and I want to think about this. Actually, let's drop a line straight down. This kind of looks familiar, doesn't it? Remember doing sine and cosine? Right? Did you remember any of that? So it's kind of has that look to it. But here's this point right here. This point right here is it's a point on the circle, isn't it? Okay, so I'm just going to call this. Now, you don't know what it is. I said it's just some random angle. Okay, there's nothing specific about that angle being a 30 degree or anything like that. It's just some random angle. So if it's some random angle, this is just some random point on the circle. And I'm going to call that random point, if you want to call it that. Call it xy. All right? It could represent any point on the circle. You follow me? So x and y represents any point on the circle at all. Now this is a right triangle. And what is this point right here?
0, 0.
That's 0, 0. Now, in order to do this, if you look in the book, they don't actually start at the origin. I do, just to make this thing make a little more sense to you. And then, but really, this equation of a circle, the center of the circle doesn't have to be at the origin. It could be anywhere. All right, but I just wanted to make it simple at first so that you could see what's going on. All right. By the way, we know this is specifically 0, 0, but here's the letters they give for the center of the circle. They use the letters H and K for the center of the circle. Now, this specifically is at 0, 0, I understand, but this could also work for any circle in any quadrant. All right, doesn't matter where the center is. It could be anywhere. It doesn't have to be right on here. All right, it could be anywhere. So what I want to do, let me see something real. Hang on just a second. All right, so we've got this point. We've got this point. We'll call this xy. We'll call this hk. What about this point right here? Any idea where that would be? Yeah, you could say that, but what if it? See, this is part of the problem with making it at the origin. Actually, I'm not making it any easier making it at the origin. But this point right here, how far did you go? Let me think if I want to do it this way or not. All right, let's try to get through this quickly. Sorry about the mix-up here. I decided to, hey, let's take this and not put it at the origin. It'll make a little bit more sense to us. This point right here. Now watch. If this point is hk, where is it right here? What's that point right here along the x-axis? Look, this is hk. Say it, Alex. It's h, right? It's just h, okay, right along the x-axis. What about this point right underneath of that? What would that be? That would be x, okay? What about this point on the y-axis? What would that be? That would be k, and what would this point across from here be? That would be y. Does that make sense? What we're doing is all we're doing is finding the length of this radius. Really, the length of this radius of any circle is basically the equation of that line. That's what they use to do the equation of a line, is just finding the length of this radius right here. Now, if I said the length of something, that would be what formula comes to mind? If I talk about the length, the distance formula. Good. So I need to find this xy, or let's do this. We're going to do distance formula. And distance formula comes from Pythagorean Theorem. So if you wanted to, you can find this distance from here to here. This is x, this is h, so this would be what? X minus h. What about from here to here? This is y, this is k, so what's this length? It's going to be y minus k. Now, we want to find an equation. We'll call that r because that's the radius of the circle. Now watch, we're almost done actually. What we're going to do is we're just going to write this as Pythagorean Theorem. All right, so I'm going to write an equation that relates all three of those sides. So this is my hypotenuse, so I'm going to go r squared equals what? X minus h squared, because that's the distance along the x. And what about this one right here? Yeah, and we add it, right, because it's Pythagorean Theorem. And that's basically where the equation of the circle comes from. It's y minus k squared. That right there is the equation of a circle. All right, so what does that mean? What does the r represent in this circle? The radius. Good. And what does the h and the k represent on this circle? The h and the k, what is that to the circle? Say it, Alex. It's the center of the circle. Right, that's the center of the circle. All right, so what they're going to do is stuff like this. They're going to say, okay, write the equation of a line if the radius of a circle is 5 and the center of the circle is at 3, 2. All right, they're saying write the equation of a line. So you say, okay, this right here is the equation of a line. Just plug stuff in. So if I plug in an r for this, or 5 in for r, what do I get? 25 equals, put a parentheses, squared. See, equation of a circle looks very similar to Pythagorean Theorem, doesn't it? So what do I put here? I put x minus the center, which is h, and then, almost done, y minus what? Oops, what am I doing? It's not just h. What is it? I know the point. Is 3, so it's x minus 3, and then y minus what? 2. What if they did this? What if they said the center of the circle was -4, -1? Radius is still the same, so it would be 25 equals x minus what? What's minus -4? It's plus 4, right? Squared plus y minus -1. What's the same thing as that? It's y plus 1 squared. And that is your equation of the circle. Now, let me just warn you, they're going to go the other way, which is actually easier. Sometimes they'll give you the equation of the circle and they'll say, okay, what's the radius and what's the center? All right, so let's work backwards. Just looking at this, what would the radius be? It's not 25, it's 5, okay, because you take the square root of that. What's the center of this? It's not +4, what is it? It's -4, -1. Very good. And that's basically all they're going to do. Let me give you some problems to work on. I think I've seen that on YouTube. That would have been funny. Let's write some problems down. It's 747. Whoops, wrong. Page 747. 11 to 18, and then I have a little break in there, and let's go 21 to 28. All right, Ryan.
What?